Hello everyone. Welcome back. Before we dive into the deep ocean of numbers today, let me ask you a simple question. Have you ever tried figuring out which IPL team scores the most runs on average? Or which subject gives you the most marks in every test? Well, whether it's cricket scores or exam marks, that's statistics in action. In your class 9 journey, you already met statistics, the art of organizing and understanding data. You learned how to classify data into two types: ungrouped data, where every individual observation stands alone, and grouped data, where we bundle similar values into class intervals. You also drew pretty bar graphs, sleek histograms, and those connecting lines called frequency polygons. Remember those? They helped us see patterns faster than reading 100 numbers on paper. And of course, the magical trio, mean, median, and mode, are numerical superheroes that represent the center of a dataset. Now, why group data, you ask? Because when you have 1,000 exam scores or population data for a city, grouping them makes life and math way easier. That's what makes statistics the superhero behind surveys, economics, and even weather forecasts. So, let's level up from class 9 basics to some serious number crunching, but in a fun way. In this chapter, we are stretching our statistical muscles. We'll take mean, median, and mode, which you've already met, and apply them to group data. Now, group data is all about creating class intervals like 0 to 10, 10 to 20, and so on, and counting how many data points, called frequencies, AFI, fall into each group. We'll also meet new friends: cumulative frequency and ogives. No, ogive isn't a French dessert. It's a curve that helps us visualize data growth step by step. There are two kinds: the less than ogive, which starts from 0 and rises, and the more than ogive, which begins high and descends gracefully. Together, they help us understand data distribution. How many students scored below 50 marks, or how many scored more than 80? Cool, right? So from summarizing small datasets, we're now stepping into the world of big, organized, and visual data representation. Now let's revisit our trio: mean, median, and mode, but this time in the grouped world. The mean, also known as the average, tells us what's typical across all data points. The median shows the exact middle, the point where half of the data lies below and half above. And the mode? That's the most popular kid in the class, the value that appears most frequently. Together, these three are called measures of central tendency. Each one tells a slightly different story about the same data. When dealing with group data, we can't list every value. So instead, we use class midpoints, the average of the upper and lower boundaries of each interval. The formula for mean looks like this: x bar equals summation of fi times xi divided by summation of fi. Or in words, multiply each class midpoint by its frequency, add them all up, and divide by the total frequency. That's your mean. Think of it like balancing a seesaw. Every frequency adds weight at a midpoint, and the mean is where the seesaw balances perfectly. In symmetric data, these three measures meet at the same point. But when data leans left or right, they drift apart, showing how skewed our data is. Alright, picture time. Statistics loves visuals, because graphs tell stories that numbers alone can't. First up, bar graphs. They're perfect for discrete data like the number of students in each house: red, blue, green, yellow, with equal gaps between bars. Then we have histograms, which look similar but have no gaps, because class intervals are continuous, like 0 to 10, 10 to 20, and so on. The area of each bar is proportional to the frequency. Next, frequency polygons. Connect the midpoints of histogram bars with straight lines, and tada! You get a polygon that shows the shape of your data. And finally, our elegant ogives, the curves that grow or fall based on cumulative frequencies. Combine the less than and more than ogives on the same graph, and their intersection point gives the median visually. Who knew graphs could gossip about our data behind our backs? showing who's average, who's rare, and who's extreme. Now that we've refreshed our graphs, let's test our statistical powers with a real calculation. Let's solve a quick one. Ready? Here's a frequency table of marks for 50 students. Class intervals 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. Frequencies 5, 10, 20, 10, and 5 respectively. Step 1. Find midpoints of each interval. For 0 to 10, midpoint is 0 plus 10 divided by 2 equals 5. For 10 to 20, midpoint is 15, and so on up to 45. Step 2. Multiply each frequency with its midpoint. You'll get products 25, 150, 500, 350, and 225. Step 3. Add them all. Total equals 1250, and total frequency equals 50. Now plug into the formula. X bar equals summation of Fi xi divided by summation of Fi equals 1250 divided by 50 equals 25. So the mean marks of the class is 25. Look, it lies right in the middle interval 20 to 30, which fits our expectations beautifully. If marks are weights on a seesaw, 25 is the perfect balancing point, the mark around which everyone's score revolves. And that's how we compute the mean for group data. Neat, logical, and surprisingly simple once you see it in action. So let's wrap up what we've learned today. Statistics helps us collect, organize, and interpret data, the heartbeat of modern decision making. We started from ungrouped data and leveled up to grouped frequency distributions. We revisited our heroes, mean, median, and mode, and saw how to compute them for large datasets using intervals and midpoints. We visualized data through bar graphs, histograms, frequency polygons, and OGIVs. All these tools together make statistics one of the most powerful branches of mathematics, connecting numbers to real-world insights. And that's our introduction to statistics, when numbers tell stories and graphs paint them. In the next video, we'll learn how to calculate the mean for group data using 3 different methods: the direct, assumed mean, and step deviation methods. So, stay curious, keep counting, and remember, math is everywhere, even in your cricket scorecard.